Good morning. I'm Mr. Coombe. Let's do a problem. If you were to dissolve a teaspoon of salt in a cup of water, what's the concentration of your solution? So to tackle this problem, I consolidated with the internet. I found out that 1 teaspoon of salt is actually about 5.69 grams. And 1 cup of water is 250 mils. So that's where we need to actually get this started. So we know a mass, how much salt we have. We also know how much volume we have. So concentration is just how much substance you have in any particular volume. So how much substance you have in any particular volume. We can express it in one of 3 ways. We can express it in mass per volume, and we express that in grams per liter, or we can do it in G/L. Okay. We can express it also in percentage. Then there's 2 ways we can express it in percentage. We can express it in percentage mass per mass, and we obviously you express that in percentage. You can also express it in percentage volume per volume. Now in this particular question, it's not as relevant because in this particular question we have a solid dissolving into a liquid, where percentage volume per volume, usually you would do it with liquids dissolving in a liquid. And we can also express it in moles per liter, which is actually the more important one. We call it molarity, and we can also express that same thing in big M. So don't get that confused with molar mass. Big M in concentration, when you talk about concentration, is molarity, which is the same as moles per liter, but we'll get there in a second. So first things first, when you're talking about mass per volume, you need to make sure that the units are the same. Mass per volume, the unit, you can actually do grams per mil, but the general convention is grams per liter. You can do kilograms per liter, but this is the general convention. So we have our concentration of our sodium chloride solution, okay, is just literally going to be the mass divided by its volume, but it needs to be in the same units. So we have 5.69 grams of our salt, and we have 250 mils. Now we need to convert, because we know that for every 1 liter there is 1,000 mils. Okay, so we know that if it's 250 mils, then we should know that 250 mils is 0.25 liters, and which should give us approximately a concentration of 58 point, apologize, nope, that's not the correct one, 23, there we go, 23.84 grams per liter. So that means for every liter of this solution, if I had a liter, obviously we don't, we only have 250 mils, but for every liter of this substance, of this solution, we have 23.84 grams distributed in it. Now there are a few assumptions here. The assumption is that you completely dissolve this salt in the cup of water. It has to be completely dissolved, and it has to be very, very well stirred, because solutions, when they're completely dissolved and they're well stirred, they are called homogeneous. When they're homogeneous, we assume that that there is an even distribution of the dissolved particles throughout the solvent. So there is an even distribution of the solutes throughout the solvent. Now this is going to be very important, because later on when you calculate masses from concentrations and amounts from concentrations, this actually becomes very, very important. Okay, so let's have a look at percentage mass per mass, and that's actually really, really easy. We know that we have 5.69 grams, so our percentage mass per mass equals 5.69 grams. Now we need to make sure that they are in the same units. Now we know that because of the specific gravity of water, 1 gram of water is 1 mil. So if you have 250 mils, the mass of our solvent. So we have 5.69 grams of salt, and we should have 250 grams of our solvent. We multiply that by 100 to get a percentage, and that should give us about 2.28% weight by weight solution. Let's have a look at percentage volume per volume. Now, usually you would do volume per volume with liquids, dissolving liquids, for example, alcohol dissolving in water. Okay, so upon consulting the all-powerful internet, I actually found out the specific density of salt. So for every cubic centimeter of salt, which is a mil, there is 2.165 grams for every cubic centimeter. So if we found out that 1 teaspoon of salt is 5.69 grams, then the volume of our salt is actually about 2.75 mils. So if that's our volume of salt, our percentage volume per volume is going to be our volume of our solute, 2.75 mils, and the volume of our solution, our solvent, times 100. And that should give us around about 1.1% volume per volume of salt solution, 1.1% volume per volume. Now notice that these numbers are different because of the density of salt. Salt is somewhat denser, it's a lot denser than water is. Water is 1 gram per cubic centimeter, 1 gram per mil, whereas salt is 2.165 grams per mil or per cubic centimeter. Alright, now there's this last and actually the most important concept, this concept of molarity. So molarity is actually really important because this is actually how we measure the concentrations of solutions in chemistry. Okay, and that is just simply how many particles, how many moles of substance do we have for every liter of our solvent, and we can express that in two ways, either moles per liter or simply big M standing for its molarity, or we'll say it's molar. So we say molar. So to find out the molarity in moles per liter first, we need to find out the number of moles of our salt solution, of our salt first, and we know that it's 5.69 grams dissolved, and to find out the number of moles, we find out the actual molar mass of our salt. The molar mass of our salt is about 58.44 grams per mole. So a number of moles of our salt should be about 9.74 by 10 to the negative 2 mole. Now we know, and this is actually the concentration, to find out the concentration in terms of molarity, there's this beautiful equation that we can actually use. We can know, you can even commit this to memory. The number of moles when talking about molarity is equal to its concentration multiplied by its volume. Or simply, if we rearrange that, its concentration of our sodium chloride solution is going to be its number of moles divided by its volume. Now remember, we need to make sure that this volume is consistent. It has to be liters, so you need to convert. So that's going to be 9.74 by 10 to the negative 2 over 0.25 liters. And that's moles up here. So it's going to be approximately 3.89 by 10 to the negative 1 moles per liter. Or the way we can actually express that another way, and this is actually the way we express it in chemistry. We can even express it, because it's not a small value, we can even express it to 3 significant figures. 0.389 molar. So the concentration of that solution is 0.389 molar solution of salt. Now I'm going to do a future episode in which we're actually going to get this same problem, and if we were to take a certain amount from the salt, how many atoms, how much substance do we have in that same amount? So keep tuned in, and we'll see you next time.